this presentation is going to be a little bit, let's say, exotic, maybe, for most of you, or if not all of you. I'm a historian of science, and so we do historical research and concerning development of scientific knowledge. And so starting from approaches in digital humanities, then moving on to so-called computational history and application of network theory and so far and so on. Then at a certain point, this project, the project that I cannot show to you because it's not turning, also, okay, I should have tested this. I can do this, but I cannot do this. Okay, there is a help button. Anyway, so at a certain point, since a few years, we entered the experience and the adventure to use machine learning for our historical analysis on different levels. And from that on, recently tried to enter the domain of explainable AI. I can't move the slides back and forth. Yeah, okay, it works. Yes, okay, thanks. So this is the project. You see, these are the project is related to several institutions. As a historian, at the Max Planck for the History of Science in Berlin, but actually, let's say the major aspects of the research are located in the frame of bifold, and you have already heard this, about this institution in this conference. So as you have to allow myself to make a little introduction to the historical studies we are doing, otherwise it's difficult to understand why we are using a machine learning or explainable AI in the way we are doing it. So the first thing is this. Our research question concerns processes of transformation of knowledge. It's about, for instance, we have already seen this conference, knowledge growth in the previous talk, knowledge accumulation, knowledge distribution, how these aspects are related to each other. So it's basically, if you want, are all aspects of studies concerned with knowledge economy. But we do it with a historical perspective. So looking in the past, when these processes were taking place, and homogenization of knowledge, if you think of scientific knowledge, now you could start studying math all over the world, or in most of the places of the world, and in the first years you would study most probably the same content. And this is the result of a process. This hasn't been always the case. And it's a process, it goes all together with many other societal and cultural changes like globalization. And this process goes back for a long time, and we are analyzing, we're trying to get to the roots of this process in the frame of the emergence of the universities as educational institution, which means late medieval period, early modern period in Europe. Early modern being 15th, 16th, and 17th century. So how do we do this? We collect a huge amount of historical sources, and then we look how the content of these historical sources has changed over time, over long periods of time, and considering large geographic regions. In particular, we have collected textbooks, university textbooks on astronomy. And astronomy, because it has been for many centuries mandatory to for all the students, doesn't matter what they wanted to do at the university, to learn astronomy, start learning astronomy, at least an introduction to astronomy in the first and second year of the university for all the young students. And see, this makes it easy for us to select a subject, in this case astronomy, so in order to have the possibility to make long-range studies and geographically broad enough. So we collected many, particularly widely spread textbooks, and we have 4 collections that they have strange names probably to you. The first one is Sacrobosco, is the biggest one, and these collections are collections of text that of volumes of textbooks that contain specific, at least one specific treatise or one specific text or one specific scientific work. And this Sacrobosco, for instance, is an introductory text to astronomy. And students would buy in the early modern period a book, a printed book that contains this text, but also many other texts together to deepen certain aspects, and you will see in a second. What it means, because this is the kind of data. Well, in a second, not, but let's say 10 minutes, 15 minutes, because this is the kind of data that we collect. So we try to see how these texts are related to each other, and our unit is always one volume, the textbook that the student was buying. We have been working mostly on the first, or exclusively in terms of analysis on the first collection, and everything you will see in terms of analysis today refers to this collection. But then, obviously, when we move to AI, this collection also means that from there we create the ground truth, the training sets, in order to go to the next collections and analyze them, which are our validation cases. So some numbers. So we have collected 477 editions of textbooks. So we take one copy of them as representative for the entire print run. An average print run for the time is about 1,000 copies. So now, from historical point of view, this means that we are moving in a range of about 450,000 books that were used by students all over Europe, and they were eventually reused, second-hand market, and all these things. So this is the geographic range of the project. From a point of view of the analysis and what I'm going to show to you today, we have about 100,000 pages of material, which obviously exceeds a bit also the human capacities. You wouldn't read, you wouldn't be so glad to read 100,000 pages of material to make your historical reconstruction. You actually can do that. This is the temporal distribution. So the first book is printed in 1472, which is less than 20 years after the very first book was ever printed in Europe, which is about 1455, the Bible of Gutenberg, the famous Bible of Gutenberg. And you see, so the production of textbooks changed. This textbook changed over time. We have a peak, and then it goes down. Not because there were no more students, but because the textbooks then changed. So then we would have new textbooks. But if we stay, our limit is always 1650, because after 1650 there are other major changes. So it means we are analyzing about 180 years here of time, which means we are going out of the generations time, which means so people who are agents involved in the production, reading, use of these books died, and then we have a new generation. So we have a temporal issue, so to speak, to take into consideration. This is the geographic distribution of the printing of the books. So you see it covers almost completely Europe. Krakow, Lisbon, and London, Rome are basically the major coordinates. So how do these books look like here from maybe a more machine learning perspective, and in terms of segmentation and classification? So these books are quite complex, actually, as the printing strategies in the early modern period, although it was a new technology, were actually way more articulated than nowadays. They were daring, more sophisticated layouts. What you see here, this is important to understand, because this is what you see here. So you have different fonts for different texts. So these are so-called original texts. So people at the time mostly produced new knowledge and new scientific knowledge by commenting on older texts. So here, basically, the author of this text is the one who wrote these texts here. And this one was already dead since 3 centuries when this book was written. But nevertheless, this is the way you would produce knowledge in this period, also much earlier, just in form of commentaries. So which means for us, we need to extract data which are quite complex in the original form, and we have already here, already in the layout, a semantic relationship between two texts. And and you would find another commentary with the same original text here, the same paragraph. The texts were dissected into paragraphs, and then here around another commentary, probably eventually speaking about completely different things. So it could be astronomy, mathematical astronomy, medicine, astrology, or many other subjects, because astronomy was fundamental for many different scientific branches and disciplines. So astronomy was necessary as for also for physicians, for instance, which is now no more the case, but at that time it was. So that's why we have quite a variety. And then we have visual material, and we will see in a second that will deepen this aspect. So there is a lot of scientific illustrations in these books. These are so-called mathematical books, and scientific illustrations played a huge role in trying to convey and knowledge and explanations in the time. As very similar to what is still happening today. So this is already there, although we are 500 years old. Yeah, 1 second, I show this one. This is, we model all our data that we extract from the historical sources with RDF model, and we have an ontology coded in CIDOC CRM. This is quite important for the humanities. Digital humanists are pushing a lot in this sense. So this is a system used by the major memory institutions like libraries and archives, the biggest ones, which means we can share data. The data is platform independent. We can share data. We can create big data sets. Because this is a big issue. If you want to make something, you use machine learning or AI in history, it means that a lot of resources go into the creation of the data sets. And so we want to, as a community, we want to provide the means to share the data sets and enlarge them, which is then good for everyone. So now, before I have the presentation wants to go into two aspects concerning explainable AI. One, it's let's say the easy one, which is also already completed. And it really concerns the analysis of these sources. So, and specifically these images that you've seen now one example, but I will show to you some further examples and how we can use explainable AI in that level. The other one is more abstract and concern more the reasoning, in this case historical reasoning. And concerns other data, text that we have extracted from the textual apparatus. I start with the images, and then I will show to you later which kind of data otherwise we have collected. So images means, or illustration means that we have, for only the first corpus, about 36,000 visual elements that we have started extracting manually. We have a taxonomy. We divide between scientific illustrations, initials, title page, frontispieces. These visual elements are there are really many different types of them. For the evolution of knowledge, of course, scientific illustrations are the most important, but actually all of these elements have a historical relevance when you need to reconstruct genealogies among historical sources, which one is related to the other, and many other aspects. So we collected all of them. Then we used also these images to create ground truths, and allow me a bit of advertisement. We created this web service that for other historians who do not have access to this kind of technology or of knowledge in machine learning, in order to quickly create data sets. So the hope is that all these kind of projects like the one you are listening about, they also have a little bit the mission to improve or to develop tools and instruments to others in order to increase the data sets and to support this kind of researches. So this is a tool to that identifies any kind of visual elements and already classify them according to their historical properties and definition. This is an initial and decoration and scientific illustrations, diagrams, and so far and so on. Then we cluster all these images for the moment, according to similarity, which means that we can immediately create a network among all our editions according to the fact as to whether they contain the same images, for instance. But for each image, we can do this network that evolves temporally and changes spatially. So the clustering works pretty well, but not 100% well. So for this, we also developed an app that allows operators, user to clean the clusters. Now this is very, very unclean, but basically it works in this way. The clusters are suggested by the algorithms, and the operator can validate them. The whole idea was to have an incremental learning engine in the background, but it was kind of too complicated. We gave up. And also, we didn't have any GPU server to use, and so that was another problem. Then what we are doing right now, and is that we are labeling all these clusters of similar images according to meaningful keywords, astronomical keywords, and which means when we will be done, and it will be very soon, we are almost done now, which means that we can also develop algorithms that are able to, let's say, to move or to help us going more to an interpretational level of analysis, and not just finding similar objects, but also objects with similar meaning. For instance, here, if you look, these are all. Each image is representative of an entire cluster of images, of similar images, for which we have all the metadata as well. And these are all clusters of images that are there to explain, for instance, the sphericity of the Earth. So this is the kind of work. So we can group the different images also because they have the same meaning. That's the point. And so you can imagine immediately how this could be used in the future. We're also developing further apps and further supportive too. But now let's move to explainable AI. So the first example, when we decided to move into this, we decided to take it easy, to make something that could be done, let's say, quickly, and see how it can be used, also to learn for us, because you can imagine there aren't so many historians working with explainable AI, and I personally never met anyone until now, and I only know two words similar to what I'm going to show to you, and they come from art history, which is more a natural application probably for that. And I read the papers last week, so they're very new. So it's starting now. It's a totally pioneering work. So how do you use explainable, and why do you use explainable AI in history? Trustworthiness is, of course, important, especially if you need all these, if you use all these tools and you don't have time or resources to check the results and so far and so on. But it is not, as long as you work with stuff that it is 500 years old, it is not that, let's say, there's super priority. It's not like in medicine where it even has legal consequences, the use of a model or not, so you need to understand the model. For us, it's by luck less dangerous. As Klaus said in his talk, in reference to another example, here nobody dies if you make a mistake. But so then the idea to use explainable AI is because we wanted to figure out cases where we can just gain more knowledge by applying explainable AI. We can just gain insights, historical insights that we are missing. For instance, because there is too much material, who is able to check 30,000 images so that at the end you remember the first? Who is able to have an holistic view of images, textual data, and other data that I haven't spoken about, but we have concerning all the numerical and mathematical apparatus of these books. So there is no way to do so. So then, if you work with AI to have this holistic view, then you want to understand how AI is making certain predictions, and maybe this understanding brings us more knowledge than what we had at the beginning. So that's why the talk is Explainable AI Historian. The idea is to develop like a partner in the group, so to speak. So then, okay, what was one easy question to try to solve, to start in? One thing you can do in history of science and technology is to try to figure out definitions of certain things. For instance, definition of what is a machine. Because now we have now a certain concept of machine that economists use, engineers used, and so on. You want to know the history of this concept. And then you go back when people started theorizing machines, and you try to figure out how they were thinking about that. And so, in the same, we try to do for mathematical instruments. Now, the question is, let's put this question: what is a mathematical instrument? A mathematical instrument in this period is something that then developed in what you now call laboratory equipment. It's to make science. It's to measure something. But if you look at the actors category of the time, they don't have any definition really. And then, but you want to define as a historian, you want to understand how we developed, the theories of instruments and the role of instruments in science from a philosophical point of view or historical point of view, and so on. So there are all questions that people, humanists, discuss. Not all of them, of course, but they do. So this seems to be a quite trivial question. It is not so trivial, however, if you look at those instruments that we have. Here, I put you some examples, so you enter into these sources. This, if you look at the top left, this is an armillary sphere. It is a mechanical reconstruction of how they conceived the cosmos to be. So they were doing measurements on these mechanical reconstructions and then transferred them in an imaginatory way to the cosmos, so to speak, about the position of the planets and so. You have a lot of dials, solar dials here, universal solar dials, so solar clocks, universal meridians. So most of these instruments have kind of scales with values because they're measuring something. Not all of them, like the Jacob stub. The Jacob stub is an instrument that was used to calculate distances by means of triangulations. But doesn't have a scale on it. You have to change the distances between these 2 points in at the bottom, and then measure them with another instrument, and then make some calculation on a piece of paper. So this is the kind of instruments here. So how do you make a definition that is not just measuring something for all of them? They are all very different from each other. So this is the kind of material that we have. Then we have, you also see here a little bit one thing that I won't speak about really, but apart mentioning it now. Obviously, all our algorithms and model work with electronic copies of historical sources, not with historical sources, not material, which means that we have to deal with a huge amount of heterogeneity on many levels. And one of them is this quality of the scans that we have. And this is the way historians work. And so we have to, our models are trained to deal with these big changes, black and white, resolutions down and up, and so forth and so on. So then we have also this kind of material concerning instruments. So here they explain with sort of over-proportional or strange images, or strange from the visual language, how these instruments work and how the operators should use them. And we have a lot of them, and they are so, let's say, unrealistic in comparison to the others that we didn't even use them because we thought we mess up everything if we use this material. But this might be used for multi-view training if you make a pixel-wise analysis of the elements and so on. So we could do that, but we haven't done. So now, then we have collected all these things. We have made the training sets, and we have divided between scientific illustrations, instruments, and machine. And then we have built a classifier, and then we applied on them explainable AI. So I move forward to the results. So what is an instrument? Correct predictions. So this is the quadrant that you have seen also before. This is an instrument to measure a lot of different things. In this case, in astronomy, usually the height of the celestial bodies over the horizon. Because this was important to figure out, I don't know, date or space, place of observation. It was used in navigation and so on and so on. So you see here, it's pretty easy going. You know, the activations are on the scale of values. So this is what so then the answer will be, what is an instrument? It's something that has a scale with values on it. And the same is true for all these for all these further instruments. These are all universal solar dials. This nocturnal is a night dial. And it's always the same. This is the famous astrolabe. It's always the same. The scale, in this case, is a bit different. But then we have borderline cases where the instruments are different. This is again another quadrant. The prediction is no more so high, it's no more so confident. It is correct, but you see that it's not just the instrument, there is a sun on it. So, which is obviously something that changes a little bit the environment. So there is something that is different. It's not just a representation of an instrument, but there is something more. It's something more about the way you would use it. It's more pedagogically more sophisticated image. Here in this case, this is not an instrument at all. It shows how changing the places over the surface of the planet, you would have different times of sunrise and sunset, and then you have the table around. This is a table around, but this seems like a scale of value, so then it is misclassified. Then you have the Jacob stab that we have seen before. It's classified as a machine because it doesn't have any scale of value. So you see, so this we did this many times by adding and taking away information and retrain every time. And by the way, Oliver made everything, so thank you so much. And if you have super technical questions, you should ask him, not me, about the model. So then we decided to add the category machines to add a sort of materiality. So here the difference is that when you show an instrument, there is always the idea that you are showing an object or something material on it. This is the way we started working on this, and then I thought, okay, let's find something else that has also this impression of materiality, and we added the machine. But then before looking at the machines, we look at the scientific illustrations. You have a few examples. These are way more abstract sorts of illustration. You find this is an explanation of the phases of the moon, how you would explain it 500 years ago. This is a representation of the cosmos with the Earth in the middle and the spheres of the planets, because this is geocentric cosmology. And you even have the angels in the Empyrean. Or this is the explanation of the partial solar eclipse, how it works. And then we have the machines. And here it's very nice, for instance, the machines are tendentially always represented in the frame of a context of use. So it was very nice, the activations are exactly on the engines. This is a hydraulic machine to lift up water. And this is the same. What this then turned out to be quite interesting for me as a historian and a person who knows this kind of historical sources is that actually most of the activations of the machines are relating more to the conjunctions between the actual mechanical elements. It's more about these conjunctions here. And probably because we trained machines and instruments both with this aspect of materiality, and all these mechanical elements are also kind of circular, like many of the circular spheric or circular scales of value. So it needed to find a difference between machines and instruments in a different way. And this is quite relevant. Nobody thought of it, that a machine is characterized by the fact that it always displays conjunctions between a mechanical device. It's also in this case, this is a super complicated machine to understand. Is a sort of three-dimensional, not perspective images. So you see, these are all the conjunctions between them, the pieces of the machine, and not the machine itself. So this was a way to differentiate. So what we are learning from here, this is just the first example because we wanted to learn how to use explainable AI. It was, let's say, the easygoing example. The first thing that we have learned from that is, apart from these details that I've shown to you, an instrument that scales of values, machine is something that has conjunctions, mechanical conjunctions also. Apart from this is that we learned that our data set was not well conceived because we always looked at what was represented in the images, like a machine, an instrument, or a scientific illustration. But in truth, these are not objects. They're not like ImageNet, where you have photos of objects or of animals. These are representation, these are drawings, these are people thinking and putting them into different contexts that is not necessarily the idea of representing the instrument as it is, but there is much more around that. So we have different layers. One is the graph, the visual language used to make these drawings, and the other one is the content of the drawing. And we haven't distinguished among them. So this is the first, and so we haven't thought of it. So we are now, okay, we have to, in this case, Explainable AI is helping us distinguishing between the different layers of meanings of this material, which is already a great result. It's just way complicated. We hope it was a bit, a bit easier to use this way. It's because these are second-order representations of objects. It's not the representation of an object directly like a photograph. There was no photography. But now let's move to the more abstract forms of using AI. And this is more an idea of how to use it than work that we have done, because we are starting right now. And I'm glad for any feedback. So for this, I have to introduce you again to other aspects of the historical sources. So when we collect a book, we have a lot of metadata, and your metadata, you know, if you have gone once in a library to search for a book, this is exactly the metadata that you use. Authors, printers, publication year, whatever. So obviously we have quite many of them, because these books are, let's say, a bit special in comparison to modern books, and we need to find these books in the archives. Sometimes they are not registered completely, and so forth and so on. So then what did we do? We have more metadata because we entered into these books and we dissected them into what we call text parts. There are portions of text, because we wanted to know whether there are repetitions and reoccurrences among these portions of text. So we cannot use natural language processing to extract data, because these texts are unfortunately not machine readable, and there is really almost no way to make them machine readable with actual technology. There is a lot of investment in this direction, OCR, machine learning, you know, but it's just the results are really miserable. So until now, although there are millions of euros invested in Europe for this, but it just doesn't work yet. So we cannot use that. So we had to dissect it in big portions. The big portion could be even a pages long text or a long paragraph. And these portions are divided semantically, when a text has a beginning and an end that makes sense in itself, and not like we couldn't do sentence-wise, for instance, which is a pity, because otherwise we cannot do. This is a limit. And then what we have done, we have connected all these text parts among them, not only because when they reoccur, so if a book in one year has a text part and then a book in another year has a text part, these two books are as the same text part, these two books are connected, true. But not only. This is the temporal view. We also have a long series of semantic connections among them. I jump there, here jump a bit, and then here. So these are the text parts. So we analyze, you remember this page, we analyze what is the original text or the reference text on which it is commented. We say whether it is a commentary, whether there is a translation or a fragment of a text, and the combinations of all this. You could have a fragment of a translation of a commentary, and so forth and so on. So in this way, if you take into consideration the many texts that we have found, because every book can have between 4 and 30 texts, 400 books, and 200 years of history. So you imagine in this way how many data we have, and with many semantic relations. So the first thing that we have done is to put this into a matrix, and the way we work is then we develop multi-layer networks where all the nodes are the books, and the books are connected to each other because of these semantic relations. Every layer is a different semantic relation among the books, and the graphs are oriented in the sense that they are chronologically oriented. And then we analyze these networks, and so we distinguish, this is a typical issue of computational history, you have to distinguish completely and very clearly between the analysis and the interpretation, so to speak, and which is something historians have difficulties with, because basically the interpretation is in the moment where you take notes, and while reading something, it's already interpretation. So here it has to be more, more separated. And then I show to you quickly what we have done with these things, because then we understand what I want to do with explainable AI. Here, for instance, we made an analysis, community detections. All these graphs speaks about the content of the books, not about the people around, and so they are not social graphs. So community analysis, community detection, in and out degrees of the aggregate, and so forth. And so on, this kind of studies, this published, this was the first paper, epistemic communities, published in the Journal for Historical Network Research. The use of networks for empirical analysis in history has established since about 10 years. It's pretty new. Mostly they use social network analysis techniques, but meanwhile, we were among the first. We used different network forms of network analysis in this case. So here we could, for instance, show with this paper that the homogenization of knowledge was actually a center emanating process coming from models that were created in the frame of the Protestant Reformation in the 16th century. So apparently these books were able to unify students and scientists all over Europe, while Europe were getting apart because of the Protestant Reformation. So this kind of historical processes, then this is more technical. I don't want to enter into details, but this is a paper we published also in scientific reports, and we were showing, again, the relevance of these models in several forms. And then what we have done is to enlarge our network, and we have now, we have now 6 new layers, for instance, all concerned with metadata. So we use the metadata to create layers, and this means that we are speaking about economic and social aspects of the people, related to the people who produce these books, who use these books, and so on. So the whole idea was to see whether these epistemic communities, the sub-regions, and the different processes that we were able to analyze, taking the graphs concerning the content of the books, also have at least a correlation with other communities we could identify between people over time, and so far and so on. So the real correlation, standard correlation analysis didn't bring us so much, because we have too dense graphs. And so these are the big books that were written in order to justify all these new six layers, so the historical justifications. What we have done, however, what we were able to do, instead of this standard correlation, we were finally able, after a long time, to really make a model of this process of circulation, accumulation of knowledge on the basis of our data. The paper has been accepted 2 days ago, and in Humanities and Social Sciences Communication. And thanks to this modeling work that we have done, we were able, for instance, to figure out that one of these layers, of these social layers, the one that expressed more the economic constraints and the economic strategies of book producers, is the one that fits best the model. So which means that our knowledge accumulation processes were mostly influenced by economic constraints of the printers, and didn't have much to do with authors and science and ideas and so forth and so on, which is, we were able to show this. So why I'm saying all this, apart to make advertisement for my project, I'm saying all this because the very first idea that we have now is, first of all, to have a guess about how other historical sources that we have not analyzed could be related to each other. In the same way as here in the very first network, I showed to you this one. This is where, where all the books are related to each other because of specific semantic relations. But we also have all the metadata. So we have cities, people, and so forth and so on. So then let's take the new corpora that we have collected, this one. So the advantage of this corpora is one, in order to make the next step in the use of explainable AI. This corpora have been chosen also because they are semantically very close to the first one. So they also speak about astronomy, and they are temporally close. We are exactly in an overlapping time, and we are geographically in the same region, and we even have some overlap in the metadata, like same people producing, same author writing. Not much overlap, but we do even have that. And there were also textbooks using the same universities. So we have a lot of semantic similarities that let us hope, let's say, that if we apply machine learning to the graphs that we have created in Sacrobosco, the semantic graphs, we can make a guess about the genealogies and the structure, how these sources are related to each other. And if you have a genealogy among sources, this is the fundamental structure, the basic structure of any historical reasoning. Before interpreting what is happening, you need to know how the sources are related to each other that you are analyzing. History is always source-based work. So that's where you start. So this is the very first thing we could do, is to have guess on the graphs. Then we have actually already the data to validate whether it's true, whether they work or not by luck. So we are finished doing this work. And then, of course, we can go to the next step. The next step is to see whether while making these predictions on the graphs, we also don't know exactly which technology, graph, neural network, and so on, or LRP, and so on. And then we might find a way to learn way more than just how what an instrument is or a machine is, but we can learn more about how sources were related to each other, and which basically means creating semantic relations among the sources. And at the end, thanks to the kind of analysis that we have done, that we could also implement in our training set, that are kind of standard analysis, most of them. And we could figure out how by means of them, we can gain insights about, the semantic evolution of knowledge. So moving to a more interpretative level as a historian, let's say. And so there are guests, of course, but as I said, so the idea is to have a development, a tool, an AI that becomes a sort of member of the team, and not just, authoritative one that then you have to take down the web service, as Andrea has shown to us in the previous talk. So where you can always ask, why did you make this decision? And this why is part of the debate in the team in order to understand this historical development. Because the difference between, let's say, what Andrea has presented in the previous talk and this talk is that in history you don't need to come to something which is wrong or true necessarily in that way as in medicine or so. You can definitely come to different conclusions starting from the same premises, and this is the beginning of a more abstract logical reasoning as presented by Andrea in the previous talk. But first you have to go there. And so this is why is actually historical discipline is the perfect place for explainable AI in this sense, and to test everything, also in the hope to give a contribution to the other application. We also do have, I think I have 1 minute left, and we do have another more complicated aspect to take into consideration. As I said, all my graphs are oriented chronologically, so the time is inherent in the graph. But time in history is not just this. It's not just the natural time where thing happens in moment t and then t+1 and so far and so on. Time is also a parameter inherent in the process, in the sense that there are people around them. There are people who have a time expectation. There is so-called, there is a difference between natural and social time, and there is also historical time, which has several layers of coding, ways of coding time into the graph, which we don't really have, and we don't know exactly how to do this. But so these graphs, as I said, they go over a generation. You need to take into consideration the temporal evolution, and for instance, if you take 50 years of influence, then the graph actually is the red one, not the entire graph. So it changes over time, and 50 years is also a guess. What does it mean, 50 years? Imagine you have a book that contains a text part, and you have then a lot of other books that contain the same text part from the beginning till the end. So it means we have 180 years, a chain of books that of 100 years. Can we say that the last one was influenced from the first? Probably not. So how long are these links, how old are the edges, can become the edges? So this is another historical question. So for how long a historical source circulating of this kind has influenced in the future, but in the past, other historical sources? So this is a super fundamental historical question. And so this, while investigating this historical question, there is no answer, or not a direct one, not an easy one. While investigating this or trying to implement this question in our investigation with explainable AI. So that will be, the top of the thing. But it's a long way to go. And yeah, and this is the beautiful thing. You see a lot of default people here, and others in other places. And so, thank you so much.